Hello students, welcome to MGC Learning. I am Manju Dilip. Today I am going to start with the 12th standard mathematics topic Binomial Distribution Part 1. So in this chapter we are going to discuss Bernoulli's trial, Bernoulli's theorem, etc. Bernoulli's trial, Bernoulli's distribution. In this video I am going to discuss mean and variance of binomial distribution. These are three topics in this chapter. This is a very simple, very small chapter, and we will solve some questions. So first we will discuss Bernoulli's trial. Trials of a random experiment are called Bernoulli trial if they satisfy the following conditions. Each trial has exactly two outcomes. If, for example, if some experiment has one outcome or three outcomes, then that kind of experiments are not Bernoulli's trials. If the trial has exactly two outcomes, then only we'll call it as Bernoulli trial. Here we are calling these outcomes as success or failure. The probability of success remains the same in each trial. That is most important, this one. So if these two conditions are satisfying with any experiment, that kind of experiments or random experiments are called Bernoulli trials. Thus, probability of getting X successes in n Bernoulli trial is represented with like this. Probability of X successes out of n trials can be represented with n factorial upon x factorial into n minus x factorial into p raised to x into q raised to n minus x. This can be written as, this is combination formula we already studied in last year. So NCX p raised to x into q raised to n minus x. Clearly, probability of x successes, that is NCX p raised to x q raised to n minus x, is the x plus 1th term in the binomial expansion of q plus p whole raised to n. Binomial theorem we already studied in the last year, so we know the expansion. So this is the n plus 1th term. X plus 1th term of the binomial distribution. This is the probability distribution of number of successes in an experiment consisting of n Bernoulli trials may be obtained by the binomial expansion of q plus p whole raised to n. So we can expand like this. If x is equal to 0, then we will take n c0 p raised to 0 and q raised to n minus 0, that is n. And if x value is 1, n c1 p raised to 1 q raised to n minus 1. If n value is 2, n c2 p raised to 2 q raised to n minus 2, etc. If x term and x value is x, n cx p raised to x q raised to n minus x. So this is the x plus 1th term, because we are starting with 0, so x term will be x plus 1 position, and nth term will be ncn p raised to n into q raised to n, q raised to 0. So the above probability distribution is known as binomial distribution with parameters n and p. N is the numbers and p is the probability of success we are considering here. So because for given values of n and p, we can find the completely probability distribution. It is represented as x follows. This we read as x follows, binomial distribution with parameters n and p. The probability of x successes, that is probability of x is equal to x, is denoted by p of x and is given by probability of x is equal to ncx p raised to x q raised to x n minus x, where x is equal to 0, 1, 2, 3, etc. n, and q is equal to 1 minus p, because we all know that p, if we are taking p is the probability of success and q is probability of failure, then p plus q is equal to 1. So q is equal to 1 minus p. Thus, probability of x is called the probability function of the binomial distribution. So this is the formula for finding binomial distribution with parameters n and p. So probability of x is equal to x is ncx p raised to x q raised to n minus x, where x is equal to 0, 1, 2, 3, etc. n. This is for countable values we are considering binomial distribution, and Poisson distribution is the expansion of this one that we are not going to study in science section. A binomial distribution with n Bernoulli trials and probability of success in each trial as p is denoted by b and p of or X follows binomial distribution of with parameters n and p. The number of trials should be fixed in this case. The trial should be independent. Then only we can apply Bernoulli trial. Next is mean and variance of Bernoulli's distribution. Let X follows B and P, then mean or expected value of random variable X is denoted by mu or expectation of X. So expectation of X is equal to N into P. The variance is denoted by var X, and the formula for that is N into P into Q. To find the standard deviation of X, sigma X is the standard deviation of X. Standard deviation of X is denoted by sigma X is equal to root of var X is equal to root of NPQ. That is the formula. Now we'll discuss some questions. A die is thrown 6 times. If getting an odd number is a success, find the probability of 5 successes, at least 5 successes, at most 5 successes. This is the first question we are going to discuss now. So here a die is throwing 6 times. So n value, number of times we are doing this experiment is 6 times. So n value is 6. Let X denote the number getting on the die is an odd number and is also success. We are considering that as a success. So clearly X follows B and P with n is equal to 6 and P is equal to, getting an odd number is the condition here. So probability of success of getting odd numbers. How many odd numbers are there in a die? 1 is an odd number, 3 and 5. These are the 3 odd numbers out of 6 faces. So 3 upon 6 is equal to 1 upon 2 is the value for probability of getting an odd number. So Q you can find out by substituting like this. So Q is equal to 1 minus P, that's equal to 1 upon 2. So both the values are 1 upon 2 here and N value is equal to 6. So probability of X is equal to NCX P raised to X Q raised to N minus X is equal to N value we can substitute here 6CX, P value also substitute 1 upon 2 raised to 6 and Q value also you can substitute 1 upon 2 raised to 6 minus X, that's equal to 6CX into 1 upon 2 raised to 6. You will get my X and minus X will cancel if you are adding this one. Now after writing like this, till here you can solve in every question. Then now sub questions we are going to start. So there are 5 successes is given, probability of getting 5 successes. Success means getting an odd number is success. So probability of getting 5 successes is P of X is equal to 5, that's equal to 6C5. In the place of smaller text we are substituting 5. So 6V5 1 upon 2 raised to 6. So 6C5, this is the combination formula, NCX formula, n factorial upon x factorial into n minus x factorial. So 6 factorial upon 5 factorial into 6 minus 5 factorial, that is 1 factorial, 1 upon 2 raised to 6. So 6 factorial can be written as 6 into 5 into 4 into 3 into 2 into 1 upon 5 factorial can be expanded like this, and find 1 factorial is 1. 1 upon 2 raised to 6 is equal to, we can cancel 5, 4, 3, 2, 1 in the numerator and denominator. So only number remaining in the numerator is 6 upon 1 upon 2 raised to 6 can be written as 64. Cancelling you will get 3 upon 32 and this can be written like this also. So 3 upon 2 raised to 5 is the answer for the first question. Now the second question, probability of getting at least 5 successes. So probability of getting at least 5 successes can be written as probability of x greater than or equal to 5. That's equal to probability of x greater than or equal to is given. 6 spaces are there. So x can take 1, 2, 3, 4, 5, 6 values. So here it is given as probability of x greater than or equal to 5. So 5 will come and 5 above value is 6. So probability of x equal to 5 plus probability of x equal to 6. So 6C5 1 upon 2 raised to 6 plus 6C6 1 upon 2 raised to 6. Now solving by using this formula, 6 factorial upon 5 factorial 1 factorial 1 upon 2 raised to 6 plus 6 factorial upon 6 factorial is 0 factorial 1 upon 2 raised to 6. So in the first case you will get 6 upon 1 upon 2 raised to 6 plus second case 6 factorial will cancel 1 upon 0 factorial value is 1. So 1 upon 2 raised to 6 will remain in the second term. So 6 upon 64 plus 1 upon 64 is equal to 7 upon 64. That's equal to 7 upon 2 raised to 6 is the value for that question. Third part is probability of getting at most 5 head successes is probability of x less than or equal to 5, that is equal to 1 minus probability of x greater than 5. So x greater than 5 is only one value, probability of x equal to 6 is the only value. So applying that formula, 6 is 6, 1 upon 2 raised to 6. Again 6 factorial and 6 factorial cancelled, and 0 factorial is 1. So 1 upon 2 raised to 6 will remain here. So 1 minus 1 upon 64, that is equal to 63 upon 64 is the answer for this question. Now some exercise questions are given to you. You have to solve it. Thank you.